number 10 here. And with number 10, we actually have three separate situations. So you need three separate force diagrams for this. So if like this one was on the test, you would need to have all three showing all the forces. Tomorrow I'll give you out a rubric so you have a better idea of what I would grade you on. But let me show you what I would do for the free bodies for this. In A, guys, John, remember you don't have to pay attention, but at least be quiet enough so you're not distracting, okay? Thank you, sir. So what is it? In A, if we're moving with this constant velocity, that means we have an acceleration of 0. And then in B, we have an acceleration. I'm assuming they're going to mean to the right. We'll take to the right as positive. And in C, they're meaning to the left. So I'm going to do three separate free bodies for this. So this is number 10 here. And I'll have a free body for part A. This will be part A. I'll have one also for part B. Basically the same setup. And then for part C, I'll have a separate one also. Alright? And in each of these, they also tell me my mass, and I tend to write that in my object, that is 4.5 kilograms. 4.5 kilograms. You could also just record that down below. But that's my inertia and my mass of this. Alright? And then in all of them, I have force P in this direction. And then, let's see. In the first case, acceleration is 0. In the second case, it tells me my acceleration is that way. And in the third case, it tells me my acceleration is that way. Right? So those are almost done, except I have some other forces going on here. I have this obviously is taking place on the Earth, so I have a gravitational force down and a normal force up on each of these. Alright, so each one would have that gravitational and normal force. And then in the first one, now I need the problem asks me, where would you put the force Q? In the first one, I know that net force or total force causes acceleration. If there's no acceleration, that means all my forces need to balance out. I'm not really worried about the normal and the gravitational force because I think those are going to balance each other out naturally. I'm in fact going to not even deal with them. But to balance Q out, I would have to have, to balance P out, I would have to have a Q, force Q in that direction. That's my free body for part A. In part B, I know the net force points to the right because it's accelerating to the right. The only way to get a net force to the right is having at least one force pointing to the right. So I'm going to guess that Q points to the right also, so that I have at least one pointing in the direction of the net force. And then for C, it's accelerating to the left. I already have P to the left. I'm going to take a chance and say that Q also points to the left. Q could point to the right. Right? And still, I could still have a net force to the left to create that acceleration. If I picked the wrong direction for Q, what's going to happen is when I figure out the magnitude of Q, how big it is, I'm going to get a negative number. And all that tells me is, hey, you picked the wrong direction. So, but I'm hoping that I picked the correct direction. So all three of these combined you would need to have for full credit on your Y if this was a problem on the test. All right, and you'd need to have these three diagrams as they're shown here. And now I'm finally ready to do my how. That'd be the top, and now I go on to the how. And we'll go on to part A of the how. We only have, let's see the information they tell us. In this case, I have no acceleration. They told me the inertia and the mass of this was 4.5 kilograms, I think. Is that right? Yep. And I only have my one equation. Sum of the forces equals mass times the inertia times the acceleration. And of course, now I can break this down into sum of the forces in the x, max, and sum of the forces in the y equals may. I'm interested in finding the force Q, which is in the x direction. So I'm going to kind of ignore the y side and see if I can get it all done in the x and not have to worry about what's going on in the y direction. So in the x direction, I'm going to look back to my free body diagram, my force diagram, and I've got two forces in the x direction. And my two forces are negative p plus a positive q. That's going to equal my mass and my acceleration, which in this case is 0 meters per second squared. And so I end up with, Q equals P. And I know P, they told me it is, for me, 5.2 newtons. So P equals 5.2 newtons. They gave it to me as negative so that I know to point it in the direction that I did in my free body diagram. But notice these are just the magnitudes. I've taken into account the directions as I've put them in. So P is 5.2 newtons, Q is 5.2 newtons. Yay. Check it out afterwards. Pretty confident. Moving on to B. In B, the facts that they give me is my acceleration is, let's see, 5.0 meters per second squared. My inertia is still 4.5 kilograms. I'm pretty confident that I'm only going to need the x direction, so I'm going to start with my one equation. Sum of the forces in the x equals max. And if I look back at my force diagram, in the x direction I have p in the negative direction, q in the positive direction, and my acceleration is positive. All right? So on the forces side, I've got p in the negative p plus q in the positive direction equals m times a, which is in the positive direction also. So let's see, I know p, what did they tell? P is 5.2, right? That's the other fact that they told me, sorry. So I want q again. I think I'll substitute in, I think I'll rearrange for q before I substitute in. So I get q is m times a plus p. All right, bringing p over to the other side. Now, put in my numbers, 4.5 kilograms. A is 5.0 meters per second squared, plus P, which is 5.2 newtons. And then I grab my handy dandy calculator. And let's see, 4.5 times 5 plus 5.2. So 4.5 times 5 plus 5.2. And I get 27.7. So I end up with Q equals 27.7 newtons. All right. And it's positive, so I picked a positive direction. This is good. Any questions thus far before we go on to part C? No, we're good? Sure, sign up book's right there. What equation do you think we're going to start with? That will be the easiest answer because that's the only equation we have for this whole section. In this case now, P and Q are pointing in the negative direction, and so is my acceleration. So I have negative P minus plus a negative Q, which is the same as minus Q, equals M times negative A. I want to solve for Q, so I get negative P plus M times A equals Q. Going to rearrange, bring the MA onto the other side, bring the Q onto the other side, so we can get Q as positive. And now it's substituting in again in 5.2 newtons plus 4.5 kilograms times 5.0 meters per second squared equals Q. And so I end up with the magnitude of Q being, let's see, negative 5.2 plus 4.5 times 5. I get 17.3. So there's the magnitude of Q in the third case. Now I need to be careful when I'm putting these into WebAssign, because in the first two cases here, I chose them going in the positive direction. So I want to make sure for A, I put in this positive value of 5.2. So I'm just going to put in 5.2. Then for B, I again picked the positive direction, so I'm putting in 27.7. But in C, I picked the negative direction for Q. So I need to put in negative 17.3. So that WebAssign knows which direction I picked for it. That hopefully will all be correct. Yay. Alright, so we're going to do number 4, but we're only going to do part C because that was the part asked for. Because the sister acceleration is this. Hopefully you got the first part correct. What was the correct answer for A? They both experience the same force. And what about for B? And that is true for both of them. Good job. All right. And then part C, if we know system acceleration, we need Tom. So we're going to do a free body here. Now, you don't have to be a great artist to do a free body. Here's a picture of the sister. Here is a drawing of Tom. All right. Now, you can just draw them as people or whatever. That's also, but you can always cop out and draw a box or a circle or whatever you want. All right. So this is the sister, and this is Tom. This would be the force of gravity or the weight on the sister. This would be the force of gravity or the weight on Tom. This would be the normal force on Tom. Normal force on the sister. If the sister pushes on Tom, that means that there's a force on the sister from Tom, and there's a force on Tom from the sister. And we know that those are equal and opposite from answering the earlier questions and from Newton's third law. So this is would be the acceleration of the sister, and this would be the acceleration of Tom. So that would be a full credit force diagram for this problem. I know in going around, I've mentioned a lot of you were missing forces or things on this. That's what would be full credit if this was a test question or a quiz question. So, one relationship we know here is that the force on the sister due to Tom equals the force on Tom due to the sister. And we can also look over here and say, okay, some of the forces in the x is MAX, and if we do this for the sister, we have the only force is FST, her mass, her inertia, I'm going to call that M sub S, and multiply by her acceleration. Both of these would be negative, so I could get rid of the negatives and just have FST equals mass of the sister times acceleration of the sister. These were both negative, yeah. That's how I got rid of it on both sides. If I do the same thing for Tom, all right, the only force on Tom is the force on Tom from his sister in this x direction, and it's positive. The inertia of Tom and the acceleration of Tom, both positive. So now bringing those together into this relationship that I know that those two forces are equal, I get mass of the sister times the acceleration of the sister equals mass of Tom times the acceleration of Tom. Right? And now I start substituting things in that I know. Let's see. What do I know? 15 for the sister, 69 for Tom, 2.3 for the sister. You have different numbers, yeah? 15 kilograms, 2.3 meters per second squared equals 69 kilograms acceleration of Tom. And so the acceleration of Tom is going to be, if I take the red and divide it by the blue. So, well, I'm rearranging my equation to get acceleration of Tom by itself, but I'm kind of doing it in my head. Right? If I want to get the acceleration of Tom by itself, I divide both sides by 69 kilograms. Right? So I'm just going to go to my calculator now and do 15 times 2.3, all divided by 69. So I do 15 times 2.3. In my order of operations, I can just divide and divide 69, and I get 0.5. So hopefully 0.500 meters per second squared will be my correct answer. Let's try putting it in. Yay! That is correct. I did 9 and 8 block. It hasn't been posted yet because I haven't had a free moment, but it will be during B block. I'll have time to upload it. All right. Yeah, sure. So number 5, tension in a rope withstand to use and accelerate a car up, vertically upwards at that acceleration. So number 5, so I have my car here, and it's got a rope on it, providing, so that would be a force due to tension upwards. It would have its weight, force due to gravity downwards, and I know it's accelerating upwards. You guys okay with calling up positive? Okay. So, of course, I start with my only equation. Sum of the forces equals inertia times acceleration. I notice that everything's in the y direction, so all I'm going to worry about is the y direction. All right? In the y direction, I've got F tension minus the weight equals the inertia times the positive acceleration. Because acceleration's up also. Oh, I have the weight, so I have a specialized from my equation sheet. I know that F sub G equals M, the mass, times the gravitational field strength. And I know that G is 9.80 newtons per kilogram, also from my equation sheet. So I'm interested in the tension. I'm going to get the tension by itself. Force of tension equals MA plus F sub G. Substitute in for F sub G. I get force tension equals MA plus MG. I'm going to group my like terms together just to make my math less numbers to put in. And now all I'm doing is substituting in. Let's see, what do I have? 1900 and 0.9. So FT equals 1900 kilograms. Nice, they gave me base units. A 0.90 meters per second squared plus, that's the acceleration, yep. Now meters per second squared and newtons per kilogram are actually the same units, so we can add those two together. I know they don't appear to be the same, but they are. And then I just grab my calculator. 1900 parentheses 0.9 plus 9.8. Those parentheses, hit enter, and I get 20,330, which I would record as 20,300. Stay with my 3 sig figs. And hopefully that's correct. I think it's going to be. So, let's check. Yay.